Good afternoon, students. Am I audible?
Yes, ma'am.
Okay. Whether the screen is visible to you? Okay. So we will wait for 2 minutes. Let the other participants join. Kindly mute yourself. Okay. So let us start. In the previous lecture, we have finished with the chapter number 2, that is unit number 2, raster scan graphics. In that, we have learned how to draw a line, how to draw a circle by using DDA and Brazenham's algorithm. Then we have seen what is the meaning of, yes, is there any difficulty? Okay, then we have seen what is run length encoding, why it is used. It is majorly used in case of compression of the file size, or it is one of the compression techniques, lossless compression method. Okay, then we have seen the different algorithms for filling the polygon. So we have seen the seed fill, and in the scan fill scan conversion algorithm, we have seen the H fill, H flag, right? So these were the contents of chapter number 4, and now we are going to start with the unit number 3, geometric transformations. So the name itself gives you idea the different transformations like scaling, translation, rotation, which is taking place on the geometric objects. And that's why the name is given as geometric transformations. So we can have a single point. It is a geometric entity. We can have a line which is composed of two endpoints. So it is also a geometric entity. So we are having the 2D and 3D geometric entities, or geometric figures, on which we are going to perform the transformations. So in 2D transformation, we are going to have a line or a point or a triangle, rectangle, any figure, any shape, which is a two-dimensional shape. And on that, we are going to carry out translation, rotation, reflection, scaling, and shearing. And combined transformation, the name itself gives you that one after another. So we are going to have multiple transformations to carry out. So for example, a triangle is given, then first you have to translate it, then rotate it, and then reflect it. So if I want to perform 3 operations on the same triangle, then we are going to call it as a combined transformation. Then we are going to see the rotation about arbitrary point and reflection through arbitrary line. So these are the points which are with respect to 2-dimensional entity. And now in case of 3-dimensional transformation, we are going to have the scaling, shearing, rotation, reflection, translation, and multiple transformation. Here also we are going to see the rotation about the axis parallel to coordinate axis. So these are nothing but the different geometric transformations which we will carry out on different 2D objects as well as different 3D objects. So these are the 2 things we are going to learn. Okay, so let us start with the transformation. So first we will see 2D transformations. So what is 2D transformation? So transformations are the operations applied to geometrical description of an object to change its position, orientation, or size are called geometric transformation. So the operation which we are going to carry out, so transformations are nothing but the operations applied to the object so that it will change its position or orientation or size. So when there is change in the position, we are going to call it as a translation. So whenever the position is changing, for example, this is your object, which is a triangle. And this triangle, I am going to move it to other location. So I'm going to move this triangle somewhere else. Here, I am not going to make any change in the shape and size of the triangle. Simply, I am picking it up and placing it in other location. So if such kind of transformation is taking place where position is changing, so position of the object is changing in this transformation. So such kind of transformation is called as translation. Okay. Then the second type of transformation is orientation. So orientation deals with rotation of the object. So here is a triangle, and whenever I want to rotate it with 90 degree, then the side which is parallel to x-axis after 90 degree rotation, that side will become parallel to y-axis, and this will be your resultant triangle. So this is your original triangle, and this will be your resultant triangle after 90 degree rotation. So here we are changing the orientation of the object, which is also called as rotation. And the third is size is changing. So when size is changing, when I am going to perform scaling on it. So this is your original triangle and I want to double it. So now the size of the object is changing, but the shape of the object remains as it is in case of uniform scaling. So we will see the types of scaling in detail, but temporarily you remember whenever it comes. Yeah. Am I audible now?
Yes, ma'am.
Okay.
Yes, ma'am.
Yeah, let me share the screen again. Okay. So we have seen the 2D transformation is nothing but the different operations which are applied on the object to change its position, orientation, or size. So whenever we are having the change in the position, we will call it as a translation. Whenever change in the orientation, then we will call it as a rotation. And whenever there is change in the size, then we will call it as a scaling. So these are the different transformations that we will observe in the 2D figures. So let us see the first transformation, that is 2D translation. So see here the diagram. So in this diagram, you are observing a box on which CG is written. So translation is nothing but simply shifting its location to other place. So this box, which is shown as blur image or background tile, so it is shown as a previous object or the previous location, and now this is the location where it is currently available. So there is change in the position of this box, and that is called as your translation. So what is happening during the translation? For example, look at this figure now, where a single point P is having x comma y coordinates. So this is your x coordinate. So this P is having x and y values. So this is your x value, and this particular thing is your y coordinate. So you are having the P point, which is having x and y values as its coordinate. Now, after translation, I will shift this point to this other location, where the new location is called as P dash. Whether the size or the shape of the object is changed? No. The point size and the point's shape is as it is. What we are changing is just its location, just its position. So we are shifting this point somewhere else. Now that new point P dash is having the coordinates x dash and y dash respectively. So what is changing? The earlier P point has been changed into P dash, and the earlier xy coordinates has been changed into x dash and y dash, where the x-intercept, that is the difference between x dash and x, this is your x dash distance. So here I am having the x dash, and here you are having the x value. Okay, this point is x and this point is x dash. So the intercept between, or the difference between these two, is considered as tx. Similarly, the current y is, the original y is this value y, and the new value is y dash, which is lying at this point. So I am having y and y dash as my original and new y coordinate of the point, right? So xy changes into x dash y dash, where what is x dash? X dash is your distance x plus this new distance tx. So tx is nothing but translation along x-axis. So this is tx value, which is translation along x. So the new coordinate is the original coordinate plus the translation factor. So I will call it as a translation factor. So tx is called as translation factor. Similarly, the new y dash is equal to y plus this ty factor. So ty is nothing but the translation factor along y-axis. So I will have these two expressions with me. X dash is equal to x plus tx and y dash is equal to y plus ty. So let us see the translation procedure in detail. First is translation is a process of changing the position of an object in a straight line path from one coordinate location to another. So this is your one coordinate point and I am moving it to the another. Yes, is there any difficulty? Okay. Then we can translate a two-dimensional point by adding the translation distance tx and ty, which are along x-axis and y-axis respectively. So we have seen that we have come to conclusion that our new x value is equal to original x plus tx, and new y is original y plus dy. So that is nothing but our translation procedure. Okay, up to this, is there any difficulty? All of you are getting up to this?
Yes, ma'am.
Yeah, okay. So that is about translation. Now next is we are going to see how to get this result, because every time we are going to get the new coordinate just by addition. But if here it is point, here it is a single point, but if I want to shift a 2D image, which may be a rectangle, for example, this is your current rectangle and I want to shift it to some other location. I want to shift it to the other location. So for that, I should have the relation between the original and the new coordinates. And that is done with the help of this addition. So simply you have to add x factor into x coordinate, that is x translation factor in x coordinate, and y translation factor into y coordinate of every pixel of this rectangle. So for every pixel of this rectangle, suppose this rectangle is having let's say 50 pixels in it around this box. So on its boundary, we can say there are 50 pixels. So in every 50 pixel, every pixel of those 50, we have to add x and y, that is tx and ty value. Then we can shift this to a new location. Okay, so a single point is shifted by adding tx and ty. Similarly, here are the set of 50 points. If I want to shift those 50 points, then every pixel will have addition of tx and ty in it. And then you will get a new location here. Okay. So that is about translation. So simply, we are having the matrix operation for this chapter. Remember, always we are going to perform the matrix manipulations in this particular chapter. So you should know how to represent a matrix, and you should know the matrix multiplication. That's it. Nothing more than that you require here. Just representation of a matrix and multiplication of matrix, that is required in this chapter. So we have seen the new x dash is original x plus tx and new y dash is original y plus ty. So we are going to write it in terms of matrix form. So this is your P with xy values, P dash with x dash y dash value, and T with tx and ty. In short, we are going to write that our P dash, that is x dash y dash, is addition of P and T. Right? Addition of P and T. So P is nothing but x and y value, and T is nothing but tx and ty values. So simply when I perform P plus T, I will get P dash, that is resultant object. So here we are going to have the P plus T. But is it possible to directly add these two matrices? How the addition is carried out here? Simply, if I am going to perform addition like this, whether you will get the same result, x dash and y dash is equal to P plus T. So what is P? P is your xy.
X plus tx.
And here it is tx and ty. Okay, and we have to perform addition of these two. Okay, we have to perform the addition. We have to perform addition. So whenever I want to perform the addition, I am going to use this x plus tx and y plus ty. So that will give me my resultant object p dash. Okay, but when I say that I want to translate a triangle with coordinates a 10, 10, b 20, 10 and c by 3 units right and 5 units up. So what is the meaning of this? I want to translate a triangle with coordinates a, b, c. So here a is considered as 1 point, b is considered as the other vertex of the triangle, and c is the third vertex. And then on these 3 vertices, I will perform the translation by using this formula. So what will happen now? I will show you the practical output, that is how it will do. So this is your origin. This is 10, 20, 30. Here also 10, 20 and 30. Okay. So A point is 10, 10. So this is your 10, 20, 30. On this graph I have drawn. So this will be your A point where X coordinate is also 10 and Y coordinate is also 10. Next, B is 20, 10. So B is somewhere here where this horizontal distance X value is 20, but Y value is same, that is 10. And C is 15, 20. So 15 is somewhere in between these two. So 15 and 20 is here. Y value is 20. So I will get a triangle vertices like this. So this is your original triangle. Okay, so this is your original triangle. Now what is my job? I want to change it 3 units right. Right means I want to shift it towards right. Right means what? In the increasing order of X. Whenever I move towards right, your X increases, right? According to our number scale, whenever we are going to move towards right, your X value will increase. That means 3 units right you have to shift. So my Tx, that is translation factor along x-axis, will become 3. And 5 units up. 5 units up means what? Whenever I am moving upwards, your y value will go on increasing. Your y value will go on increasing as soon as you move upwards. So your ty will become 5. Okay. Now my question is, if I would have said 3 units left and 5 units down, then what will be your translation factor? So instead of right, I will tell left, and instead of up, I will say down. All of you are getting my question? Here, I have given the question as 3 units right and 5 units up, and that's why your Tx and Ty are 3 and 5 respectively. But if I want to move this triangle 3 units towards left and 5 units down.
-3, -5.
Yes.
-5.
Right. Because the current value of X, whatever it may be, whenever I want to move towards left, then the x get reduced, and reduce means what? You have to perform the minus operation. So your left side tx will become -3 because I am moving this object towards left hand side. So x value will definitely reduce, and that's why -3 will be your tx. Similarly, when I want to move this object downwards, so I will shift it downwards. At that time, your y value will also become less. So current value, suppose it is 10 here for this point. I am moving it 5 units down, means it will become 10 minus 5. So the resultant value will be 5 in this case. So ultimately, your y value will be also changing, and it is equal to the y-intercept or the y translation factor is -5. Okay, so you have to keep track of the directions while solving such problems. So this problem, which is the original one, it is having 3 units right and 5 units up value. So I am having tx equal to 3 and ty equal to 5. So by performing addition of tx and ty in our original ABC, we will get the resultant a dash, b dash, c dash. So let us solve this problem. So green I am showing with original values, and red I will be showing with the new values. So I will have here a dash. So what is the formula for a dash? The formula for a dash is
A plus T.
yes. So original a plus t. So what is a here? A is 10, 10, because a is having x and y coordinates as 10, 10. So I will write here 10, 10 plus t value. T is tx and ty are 3 and 5 respectively. 3 and 5. Okay, 3 and 5. So after performing this addition operation, I will have a dash, that is resultant value, as 13, 15. 13, 15. So I will have somewhere here 13 and 15 somewhere here. So whenever both of the point will intersect, this will be my new a coordinate. Okay, so I have shifted it 3 units to the right and 5 units up. Okay, next. Similarly, I will carry out b dash and c dash. So what is the b dash final value? In that, I have to take b 20, 10 and add 3, 5. So instead of 10, 10, I will have 20, 10 and plus this factor as it is. So this is same. So 23 and 15 will be my result. So I will have this 23, 15 as the result. So it will move here 23 somewhere over here and 15 on the same line. Okay, so this will be your new B point. And for C, perform 15, 20 plus 3, 5. So C point, I will get the new C dash will be 15 plus 3, 18. And 20 plus 5, that is 25. This is your C dash, 18. So this is your 15, 16, 17, 18 somewhere here. Okay, somewhere here, that is your 18, and 25 is 20 plus 5 somewhere over here. So whenever both of them will intersect, that will be my new point C dash. So finally, I will perform the joining of these 3 points and I will get the resultant triangle A dash B dash C dash. Okay, so that is about the translation of two-dimensional triangle ABC. So this was our original ABC green and the red is A dash B dash C dash. Whether the shape and size is changing? No. We have just shifted the object to a new location, that is our translation operation. Getting it, all of you?
Yes, ma'am.
Right.
Yes,
So
ma'am.
yeah, so try to solve a problem which I will give you right now. You have to translate a rectangle so just note down the coordinates of a rectangle. Let us say ABCD is the rectangle. You have to translate this to its new location where A is 10, 10, B is 30, 10, C is 30, 20, and D. Can you tell me the coordinates of D if it is a rectangle?
10, 20.
Right, very nice. 10, 20. Okay, so these are the 4 coordinates and translate this rectangle ABCD diagonally along y equal to x-axis, diagonally along y equal to x-axis, downwards with 3 units or with 5 units towards left and 10 units downwards. You have to shift this rectangle diagonally along y equal to x-axis with 5 units left and 10 units down. All of you understood the question?
Yes, ma'am.
Okay. So now tell me the resultant first tell me the T matrix and then tell me about the resultant parameters.
Hello, ma'am.
Yes.
Why you have written P dash equal to P into T in slide?
Yeah, I will tell you afterwards. Just remember that I have written here P into T for some other reason. Because in case of multiple or combined type of transformation, you need to perform the multiplications everywhere, not additions. Right? Or simply whenever I am having a, let us say earlier triangle, here 10, 20 and 15. Right? Here I am having a two-dimensional triangle 10, 10, 20, 10 and 15, 20. So here, as it is a two-dimensional object and it is having the 3 coordinates, I cannot simply add 3 and 5 to it. because X and Y are written in this fashion horizontally along a row. So I just cannot add like this. Can you perform addition like this in matrix?
No.
No. Yeah. Here for that purpose, if I want to perform the translation, then I have to consider one by one element or one by one pixel at a time. Then only I can go on performing addition. But if suppose this is your original, that is A, and this is your translation matrix T, then I should get some formula so that whenever I will perform multiplication between them, I will get my new A dash or simply P. And that is nothing but my requirement in case of combined transformation. Just here you can go for one by one pixel. But when I want to go for rotation, reflection, and then translation, at that time, I cannot go on individual addition like this. And for that purpose, I should find out some translation matrix in which when I multiply the original object with this, I will get the resultant one. So we will come to this point later. First, you solve this expression and get the result and tell me. So what is the T matrix?
Minus 5, minus 10.
-5, -10. All of you agree with this? Or is there any difficulty? If you have any difficulty, get it clear right now, because you will be finding other problems. So this is very simple we have started with. So if you are able to solve these problems, then you will be easily solving the further one. So these are the very small problems. So A is here 10, 10. Then B is 30, 10 here. Then C is 30, 20 here. And D is here. So this is your ABCD original rectangle. Okay. All of you are getting this. So this is your original rectangle ABCD. Now what I told you, you have to shift, you have to translate this object along y equal to x-axis diagonally downwards. So this is your y equal to x-axis. And you have to move this rectangle downwards diagonally. So in this direction, and the tx and ty is given as you have to move 5 units towards left, 5 units towards left hand side. So when I want to move left hand side, the x value will reduce. And for that your tx will be -5. So I will have -5. So tx and ty value, that is -5 is your tx value. And what about ty? It is said you have to move downwards by 10 units. So 10 units downwards. So downward will also cause y to reduce. So y will also reduce, and you will have the translation matrix as -5, -10. So translation along x is -5, translation along y is -10. And when I will add this 4 coordinates or 4 vertices A, B, C, D with this translation matrix, then I will get the resultant value. So what is the resultant? I will denote it with green now. So what will be the A point? Can you tell me the A coordinate after performing the addition with this? I will get x value 10 minus 5, that is 5, and 10 minus 10, it is 0. So A dash, I will write here A dash as 5, 0. All of you agree with this?
Yes, ma'am.
Yes, ma'am.
Okay, so 5, 0 is my resultant coordinate. So it will lie on x-axis somewhere here. Okay, 5 and y value is 0. Next is what will be my B coordinate after translation?
25, 0.
25, 0.
Yes, 25, comma 0. So where it will lie? Again, it will lie on the x-axis. This is my 10, 20, and this is 25. So I will have somewhere here my B point. That is, this is your A dash, and this is your B dash. Okay. Now what is C dash?
25 and 10.
Excuse me. 25 and 10.
10.
Okay. Right. So I will have here 25, comma 10. So 25 is this point and 10 is here. Okay. And the last point is D. It will be 5,
5,
5, 10. Right. So 5, comma 10 is my D dash. So this is your C dash. And 5 and 10 will be your D dash. So this is my resultant rectangle. This is my resultant rectangle. So have you seen the diagonal movement along this y equal to x axis? Right. So I am moving downwards along this axis by 5 units towards left and 10 units towards bottom. Okay. All of you are getting it now?
Yes, ma'am.
Yes. So simply shifting the x by tx value, simply shifting the y by ty value. It can be addition, it can be subtraction, and you will get the resultant object without change in its shape and size. Only moving the object from one location to other. Okay, so that is our translation. So now if I want to get the formula in terms of matrix multiplication, how I should move further? And for that purpose, the solution is homogeneous coordinate system. So what is homogeneous coordinate system? That we will see in the coming slides. So only remember that we have to perform addition, isn't it? Here x is changed into x plus tx. Your original x has been changed into x plus tx. So we have to write a translation matrix in such a way that instead of multiplication, I should get addition. Instead of multiplication, I should get addition. So here I will write, let us say P dash point as our earlier example, this P dash is equal to, let us say this is your x1, y1. This is your x2, y2. And this is your x3, y3. So 3 coordinates are there. So I will write here x1, y1, x2, y2, and x3, y3. Okay. Now I have to multiply it with some matrix where ultimately after this multiplication, I will get x1 plus tx. So where I should write this tx now? So for the multiplication, you are knowing that what should be the order of this matrix? What is the order of this matrix? P. This is your P matrix. This is the resultant P dash. And this is your T matrix. So can you tell me the P dash, what will be the order of P dash now? Can you tell me the dimensions of P here? 3 rows
3 by
and
2.
2 columns, right? So I am having here 3 by 2. 3 by 2. So if I want to perform the multiplication here, what should be the order of this T matrix?
2 into 1.
2 into 1, right? 2 into 1. Then ultimately, what is the order that I will get here in P dash?
3 into 1.
3 into 1 only. But I should get 3 by 2 because P dash is also my triangle only. And P dash will also have A dash, B dash, C dash with x1, y1, x2, y2, x3, y3 dash. P is what? My triangle ABC, right? Which is having x1, y1 value, x2, y2 and x3, y3. Similarly, after performing this multiplication, I should get the resultant triangle with A dash, B dash, C dash, which should also have these 6 coordinates x1 dash, y1 dash, x2 dash, y2 dash and x3 dash, y3 dash. ओके. मग जर मला 3/1 च्या ऐवजी 3/2 हवं असेल तर मला काय करावं लागेल?
Order of T will be 2 by 2.
Yes, order of T will be 2/2. Okay. Now again the question will arise, if 2/2 is the order, where to write Tx and where to write Ty? Right. For that purpose, we are going to use homogeneous coordinate system in which the matrix, instead of a two-dimensional matrix, we are going to add one more dimension to it, and which is called as your third factor. So here I will be having total element 1 as my third factor. So order of this will become 3/3. And again, the order of T also will become 3/3 in such a way that the first 2/2 matrix will be its identity matrix. जर हा आयडेंटिटी मॅट्रिक्स नसेल, समजा इथे मी Tx आणि Ty लिहिलं तर काय होईल? समजा इथे मी Tx आणि Ty लिहिलं तर काय होईल? x1 into Tx होईल, पण आपल्याला काय हवंय? x plus Tx हवंय, बरोबर? When I'm going to perform the multiplication like this, what will happen? Perform multiplication. First row will multiply with first column, right? First row will multiply with first column. So I will have here this multiplication with this. So x1 will get multiply with Tx, and that is not required. What we require is x and y should be as it is. X and y should be as it is. And if I want to make xy as it is, it should be identity matrix. It should be unit matrix. Then only it should be unit matrix. Then only I can keep x and y as it is. See here, x1, y1. When multiply with 1 and 0, x1 remains x1. Similarly, x1, y1. When multiply here, y1 remains y1 as multiplied with one factor. And now this one plays important role. Due to this one, I will be putting here Tx. So what will happen? When I am going to multiply this, x1 remains as it is, y1 will be 0 and plus Tx will be done. So x1 plus Tx is the ultimate result that I will get over here. Similarly, when I am going to multiply this first row with the second column, I will be adding here Ty so that x will become 0, y1 will remain as it is when multiplied with 1, and 1 into Ty, that is addition of Ty, will take place in the y. So ultimately x1 will become now x plus Tx. Y1 will become y plus Ty, and this value will remain as it is 0, 0, 1, the remaining identity matrix, remaining unit matrix. So now when I perform the multiplication, what will be the resultant value? After matrix multiplication, what I will get? First row, first column. Tell me the output. x1 plus y1 into 0. So plus 0 plus 1
TX.
into tx, that is tx. So this is nothing but your x dash value, x1 dash we can say. So x1 dash is your x1 plus tx in short, right? Similarly, what is y1? What is the multiplication of first row and second column? So first row x1 into 0, that is 0, plus y1 into 1, that is y1, plus this 1 into ty, that is ty. So what is this? y1 plus ty. So what is y1 plus ty? It is your y1 dash, which is our required formula. X dash is x plus tx and y dash is y plus ty. So ultimately I am going to get the same thing. And last is this multiply with the third column. So 1 into 1 will only remain, and that is your additional value that I have added here. 1 remain as it is. Getting it? So here what we have done is we have multiplied every row, and ultimately I am going to get the result as x2 plus tx and y2 plus ty, and 1 in the third column. Similarly, the third factor is x3 plus tx and y3 plus ty, and 1 as it is. So the resultant triangle will have the translated coordinates. Getting it? So here it is the use of homogeneous coordinate system that we will learn in more detail in the coming lectures. But for that time being, you have to remember the formula for translation in terms of matrix multiplication. So if I want to carry out the translation, then it is the original matrix multiplied by this t, where t is written in this fashion. The identity matrix, only the x and y intercepts are written as tx and ty respectively. Getting it? Girls side. Girls side, all of you are getting it?
Yes, ma'am.
Okay, boys, all of the boys getting it?
Yes, ma'am. Yes, ma'am.
Okay. So the small work for you is you have done the calculation for this, right? A, B, C, D. This rectangle you have done the calculation. Simply put the values of x1, y1, x2, y2, x3, y3, x4, y4 and perform the multiplication with the T matrix by putting Tx and Ty value over here as -5 and -10. And then check whether you are getting the same resultant values. So I will do the things here. I will use some different color so that your confusion will not be there. Okay. So original matrix x1, y1, 1. So x1, y1, that is 10, 10, 10, 10, and 1. This is your point A. Then point B is 30, 10, and 1. Next is your C, 30, 21, 30, 21, and the last is 10, 20, and 1. Up to this, is there any difficulty? All of you have understood what I have done?
Yes, ma'am.
Okay. Simply this A point I have kept here, and this column as it is in the last. Next is now I will multiply it with the Tx, Ty, which is a 3 by 3 matrix. In that Tx and Ty value, I will put -5 and -10. right? These are your Tx and Ty values. So I will perform the multiplication with 1 0 0, then 0 1 0, and the Tx Ty values are -5 -10. So here it is your -5, here it is your -10, and 1 as it is. Okay. So this is your P into T. So this P is having the order 4/3, and this is having the order 3/3. So ultimately, what is your P dash order? Order of P dash. Order of P dash will be 4/3. Multiply of these two matrices. You will get the order of the P dash as 4/3 as a result. Now tell me what is the outcome you are getting. 10 into 1, 10, 0, -5. So 10 minus 5 is 5. Then the first row and second column. So 10 into 0, 0. 10 into 1, 10, minus 10. So 10 minus 10 is 0. And this column, this row into this column, only 1 will remain as it is. So have you got the first point 5, 0, 1? Yes. So after performing the translation by using this translation matrix in the matrix multiplication process, I will get the resultant A dash like this. So A dash is nothing but your coordinate 5, 0, 1. Similarly, go for the second row, first column, second row, second column, second row, third column. So 30 minus 5, it is your 25. 30 into 0, 10 into 1, 10, minus 10, that is 0, 1 as it is. Similarly, so this is 25, 0. It is your B dash. Similarly, check whether you are getting the same result for C dash and D dash as per our earlier results. Okay. Getting C dash as 25, 10, 1. Yes. Multiplication of this third row with multiplication of this third row with first column, second column, third column. You will get these three entities. So 30 into 1 minus 5. So it is your 25. Here 30 into 0, 20 minus 10. So 20 minus 10 is 10, 1. And the last is 10 into 1, 10 minus 5, that is 5. Then 10 into 0, 0. Then 20 minus 10, that is 10. 5, 10, 1. So this is your resultant values which we have received here. Getting it, all of you? Yes. So here onwards, we are not going to use this addition of two matrices. Instead of that, we will be using the here multiplication. And in multiplication, remember that this is your unit matrix of 3/3. Am I audible?
Yes, ma'am.
Yeah. So this is your unit matrix of 3/3. Only these two elements will be replaced by Tx and Ty respectively. So ultimately you will get the result. Okay. So we will stop here for today.